This is the Eastern Washington Low Impact Development Guidance Manual. Part of the project team is Robin Kirschbaum, a professional engineer with HDR Engineering. She is the primary engineer for stormwater for HDR in Washington State and is involved with many stormwater related projects, including low impact development projects throughout the state of Washington. She has been an important part of this project and provides the technical expertise that has really been invaluable to this project. I'd like to welcome Robin here today, and we look forward to her presentation.
So we are going to move into Chapter 3 now, which is Designing for Low Impact Development. Len covered the introduction of the manual and the planning process. Now we're going to talk about the design process. So Chapter 3 has a design process overview, then specific strategies for residential design and commercial and industrial design. The design process really starts, as does the planning process, with reviewing your goals for the project. So LID is very versatile and can meet a lot of different goals for a site. Some examples would be low impact development can help meet requirements for core elements 5 and 6. Low impact development can be used to retrofit existing sites to improve water quality and sometimes achieve other goals in a retrofit project. It can also be used to reduce water and energy demands, improve neighborhood aesthetics and mobility, and can be a big part of reducing or eliminating combined sewer overflows. What your goals are for your project are definitely going to dictate the process that you go about for design. And so it's very important to start your design process with clearly articulated and agreed upon goals. The next step in the design process is to identify the applicable design standards and requirements. Obviously, those are going to vary for different jurisdictions. The Eastern Washington Manual provides guidelines on LID design, but local jurisdictions provide requirements that are specific to your project location. So as a designer, you need to identify, review, and thoroughly understand those requirements that apply to your site. Some examples would be setback requirements for infiltration facilities. Those you're going to find in your local requirements, not in the Eastern Washington LID Manual. Setback requirements for structures. So for example, if you have a cistern at the side of a building, you may not be allowed to have a structure, that close to a property line. You need to be aware cisterns are considered structures. Just as an example, soil and subsurface hydrology evaluation, we've provided some guidelines for how to conduct that evaluation, but local jurisdiction requirements may trump. Sizing methodologies, we're going to show you an example of how you might conduct sizing for low impact development facilities, but again, you'll want to consult local jurisdictions. Then the next step in the design process is to select the LID solutions that match your goals for the project and also respond to the opportunities and constraints of the project, which you would have found through that site mapping process that Len just ran us through. So again, example project goals, meeting core element requirements, improving transportation safety and neighborhood aesthetics. The site opportunities and constraints that you find through that site mapping process, you want to bring those together and select low impact development facilities that respond to both. And we're going to practice this in our exercise. This is steps for design of infiltration BMPs, as well as non-infiltration BMPs. And I'm going to run through all of the BMPs that are included in the manual when we cover Chapter 4. We have some very specific guidance on how to do design for infiltration for LID sites. And the stepwise guidance is: number 1, select a location for your infiltration BMPs, perform preliminary BMP sizing, develop a trial infiltration geometry, then complete detailed characterization, determine the infiltration rate in more detail, and size the facility using approved hydrologic modeling methods. And again, we're going to practice all of these steps. These steps for designing infiltration facilities are from the 2004 Stormwater Management Manual for Eastern Washington. Sizing of LID BMPs, Appendix C of the manual provides a step-by-step hydrologic modeling process for sizing LID BMPs. And again, it's based on the 2004 Stormwater Management Manual for Eastern Washington, mostly from Chapter 4 of that manual. The examples we provide use level pool routing, and We provide consideration for rain on snow and snow melt, how to factor that into the sizing of your facilities. And then we provide hypothetical sizing examples for all of the 4 Eastern Washington climatic regions. So you can see how the rainfall and the snow melt might vary across Eastern Washington and how that would affect your resulting LID BMP sizes. All right, switching gears to low impact development for residential projects. So in the manual we discuss low density and high density residential projects. And for low density residential projects, overall site planning concepts need to include minimizing driveway lengths where appropriate, using permeable pavement driveway surfaces where BMPs are appropriate, preserving open space and native vegetation, and conserving native site soils. And similarly for high density residential projects, the goal is to reduce your total impervious area, or referred to as TIA, and to minimize the effective impervious area and concentrated surface flows. Effective impervious area is when runoff from those impervious areas is directly connected to a pipe or to a receiving water body. So if you have a very small piece of impervious area and the runoff just runs off to adjacent pervious areas and doesn't really affect a receiving water body or overload a pipe segment, that would be non-effective impervious area. And by contrast, if you have a lot of impervious area and it's connected via pipe very efficiently to a receiving water body, that's called effective impervious area. So we want to think about the difference between those two, and we want to minimize effective impervious area. We want to use infiltration BMPs as our preferred method for meeting core element requirements 5 and 6 for flow control and water quality treatment. We want to minimize site disturbance, avoid sensitive areas, and promote open space connections, and provide safe and efficient fire, and this is LENS abbreviation EVA. First thing that you're going to want to do when you think about designing parking lots with low impact development is assess the required parking. Sometimes compact parking spaces may or may not be allowed. Local standards are going to dictate what the minimum amount of impervious area required for your parking lot is going to be. Provide incentives to reduce parking. So for example, bicycle facilities in the building or carpool spots or what have you. Allow compact spaces to reduce your total impervious area. Consider structured parking where the density and land values would warrant that type of approach. Use permeable pavement materials. You can see in this image at the bottom here, the concept shows permeable pavers for the parking stalls, and then porous asphalt rather for the drive lanes. So you can use different surfaces for the different parts of the parking lot, as might make sense. We're going to practice using some of these different concepts in the parking lot this afternoon. Integrate bioretention into the parking lot islands or planter strips. That's another very obvious LID opportunity for parking lot application. As Len mentioned, landscaping in parking lots and other parts of a site used to be mounded, but it's very easy to make it be depressed and make it ready to receive stormwater runoff and provide water quality treatment. So again, we'll look for those opportunities when we're out doing our demonstration exercise this afternoon. And encourage cooperative parking agreements. And then LID for buildings and strategies for minimizing storm flows and disturbance. Reducing the building footprints by designing taller structures where codes would allow for that, or in some cases incentives may be in place to prefer that. Using vegetated roofs or heavily landscaped rooftop patio areas is another excellent opportunity to reduce impervious area in a basin and reduce the impact of a building site. Another strategy that lends very well to buildings, capturing and reusing rooftop rainwater. Cisterns can be a good way to do that. Directing rooftop drainage to splash blocks and to rain gardens. So there again, that would be a way of turning impervious area into not effective impervious area by disconnecting it from the pipe system and routing it to these softer facilities. Use of minimal excavation foundations, especially with a high, in areas where you have a high water table or shallow depth to bedrock. This can be, obviously this is not a BMP that would lend itself to retrofit. It would be more for new development projects. But minimal excavation foundations are an excellent way to make a site be buildable where it might otherwise not be buildable using traditional foundations, and to also preserve the hydrology of the site. Limiting clearing and grading to the street, utilities, building pad, landscape areas, etc. So we want to try to minimize clearing and grading of the site in order to get all these facilities in there. How do we prepare for worst case scenarios, which could be intense rainfalls, freezing conditions? We do address these types of factors, especially in Chapter 4 under each different LID. We talk about what what you might want to think about. For example, bioretention. We talk about how you might want to use an underdrain if you're really concerned about freeze-thaw conditions, and that if you were to use any orifices to control discharge from that underdrain, you want to size them in consideration of freezing conditions. For example, a 1/4-inch diameter orifice would probably be a bad choice because it might be more prone to clogging during freezing. As well as just sediments might more easily clog it. So we provide those types of specific guidance on some level in the manual. What kind of water quality treatment benefits do you get from permeable pavement? And the answer is that there's a lot of there's a lot of data out there across the country that shows that permeable pavements can provide some very good water quality treatment. A film will oftentimes develop in concrete, for example. If you're using a pervious concrete, you can get a film of bugs that'll form in the aggregate of the concrete and actually provide treatment in the surface. And EPA has published some data. There's data from a variety of sources available that show that it actually works very well for nutrients, metals, other types of pollutants. But it's not an approved treatment BMP by Ecology as of yet. So you can't use it to meet your treatment requirements if your project triggers core element requirements. So if you're doing a retrofit project and the core element requirements are not dictating what you do, and this is an example of why establishing your goals early on is so important. Because if you're doing a retrofit project and your goal is water quality treatment, permeable pavement might be a good choice to help you meet that goal. But if you're using LID to meet your core element requirements because it's a new development or redevelopment project, then you would not be able to credit your permeable pavement against those core element requirements. So the question is, what if you use a treatment train where you put a different type of BMP downstream of the permeable pavement? Would you then be able to get treatment or credit for providing water quality treatment? And the answer is yes. The permeable pavement could actually, in that case, help you reduce flows to that downstream BMP. So it can actually help you get better performance from that downstream BMP. And as a system, then you would expect to be able you would size so that as a system you meet your water quality treatment requirements if the core elements apply. The question is, can we use UICs, which are underground injection control facilities that deliver stormwater runoff deep to subsurface horizons? And the question is, can you use that kind of BMP to get treatment? And Doug, you can correct me if I'm wrong here, but if your soils are demonstrated to meet the soil suitability criteria, then which Ecology is defined in the 2004 Stormwater Management Manual for Eastern Washington, if you meet those criteria, then potentially you could use native soils to meet your treatment requirements. But you would have to demonstrate through monitoring, testing, that your native site soils do meet those criteria before counting on those for water quality treatment.
And another question would be just...
The question is, given that the goal of water quality treatment per the core element requirements is to remove 80% at least of your total suspended solids, then wouldn't permeable pavement be a good BMP for doing that? And the answer is similar to the answer I gave previously, that the data does show that permeable pavement is very effective in reducing solids and metals and nutrients and other types of pollutants. but it's not yet credited for water quality treatment. So again, if you're using it in a retrofit mode, in my opinion, I think it would be reasonable to expect some water quality treatment. But if you're using it to actually meet core element requirements, you would not be able to do that. The question is, how does low impact development relate to FEMA floodplain delineation? The answer that I would give is that some communities are actually starting to develop incentives as part of their flood management program for doing low impact development. You know, generally it's best to locate development, whether it's conventional or low impact development, outside of a floodplain. That's unfortunately not always possible, and unfortunately it doesn't, you know, always happen that way, but that would be certainly the best advice would be to not be there in the first place, regardless of how you're going to do the development. If for some reason you are going to be in a floodplain, you know, low impact development, you know, could help to some degree, but there's really no formal connection between the two, other than incentives that I've started to see emerge in some locations.